Let's look together at the first question from our Quadratics applications work. It says a ball is thrown from the top of a building. Its height, y, in feet at any given time, x, in seconds, is given by this equation. Y equals negative 16x squared plus 240. The question is asking us to find the maximum height of the ball. Now, before we go and look at the graph of this particular equation, I'd like to focus on the description that we see in the question. It notes that a ball is thrown from the top of the building. However, if we look really carefully at the equation and the way that it's written, we may see that there might be a better way to describe the motion. Let's look at this first term. It's negative 16x squared. From our time in class, we've seen that this is actually the acceleration due to gravity. This term is negative because it acts on the object in a downward direction, towards the ground. Alright, now the second term in the equation is positive 240. Notice that this is a constant term. It has no variable with it. And we have seen from our observations of objects in free fall that this describes the starting position of the object before it is released. Now, notice that we are missing a third term. There is no linear term. What I mean by that is that there is no term that is multiplied by just x or just time. So we're missing that bx term in the middle of the quadratic equation. What this means is that the human or the machine, whoever it is that's throwing the object at the top of the building, they are not supplying any additional velocity. So there is no effort upwards or downwards other than just gravity. With that in mind, with the absence of this linear term, that middle term, we might choose to describe this object as being released or dropped, because it isn't exactly being thrown. If it were being thrown, we would expect to see some kind of a term such as plus 30x, or perhaps if we were throwing the object downward, we might see minus 30x, where we launch the rock downwards towards the ground. But we don't see any term like that. In fact, we see no linear term at all. So the ball is actually being released or dropped from the top of the building. Okay, now it's asking us what's the maximum height of the ball. I think at this point it might be a good idea to go ahead and look at our graph. So from our graphing calculator, I'm going to go to the y equals screen, and I'm going to enter the function exactly as I see it. It'll be negative 16x squared plus 240. Now, when I hit graph, I'm not going to see exactly what I'm looking for. I'm going to see the zeros or the roots, the x-intercepts of the parabola, but I'm not going to be able to see the vertex. And this is due to the fact that the default settings on the graph show me from negative 10 on the y-axis up to positive 10. And we can see from the equation that we need to be able to see at least from 240. So what I'm going to do is adjust my window settings. I also know that I'm not really interested in either quadrants 2 or 3 for now. And this is due to the fact that negative time has no meaning in this particular story. So I'm going to click window here, and I'm going to adjust the window settings. Since time in this story begins at 0, I'm going to go ahead and set my minimum x value to 0. Next, I'm going to leave my maximum x value set to 10. So in other words, I'm going to see a timeline of 10 seconds along the x-axis. I'm going to keep the x scale at 1, which means that every tick mark will show 1 second. Next, I'm going to adjust my y-axis so that it has a minimum value at 0. This will show the object when it hits the ground, but nothing below it. Next, my y maximum value. This is where I want to be really thoughtful about how I choose my window. I definitely want to be able to see 240, but I'd also like to be able to see a little bit above that. So I'm going to go ahead and set this to 300. And I'm going to count my y scale by 50. Next, I'm going to hit graph once more. And I'm going to be able to see that parabola much more clearly. Notice I'm only seeing quadrant 1 here, all of my positive x values and all of my positive y values up to 300, and over here up to 10. Now I can see very clearly here, this is when time equals 0 and the rock is being held at the top of the building. What I really want to do though is hit trace, and I'd like to use the trace button to kind of zoom in over here at this moment in time. I'd like to know, does this object go any higher? So I'm going to hit zoom in, option number 2, and hit enter. Okay, here's what I see. It looks like the maximum value occurs right here on the y-axis. In other words, once I release the ball, it won't go any higher. And this makes sense because there is no linear term. There is no term in the equation that shows me sending the object up any higher. It just gets released and gravity takes hold. So it turns out that the maximum height of the ball will indeed be the vertex, which happens to also be the y-intercept of this function. The maximum height of the ball will be 240 feet. And this corresponds with the y value of the vertex and the y-intercept of the function.